Hi, second year students. It's math with AUB with exercise 1.1 that is based on especially how to find domain and range of the function, how to describe perimeter in terms of area, area in terms of perimeter, circumference in terms of area, volume in terms of and so on. The simple familiarity from hyperbolic identities, how they differ from the trigonometric identities, even odd function as well as parametric equation. As there is a dearth of the space, let me start in retrospective fashion, in reverse fashion, in order to generate space for myself. So we are going to start from question number 9. Decide whether the which one function is even or odd. Even or odd, it's simple terminology. Just replace x by minus x. Just replace x by minus x in a function and the function is unaltered. Replace x by minus x. If the function is unaltered, no change, then this is the definition of even. F of x is even. F of x is even. Replace x by minus x. Replace x by minus x in overall function. If there is no transition, no change, the function remains same. It is the definition of even function. While if we replace x by minus x and the symbol of whole function changes, and the symbol of whole function changes, that the definition of odd function, then f of x is odd. If f of x is odd, replace x by minus x to check whether it is even or odd. If replacement of x by minus x gives us no change, no alteration, no change, no transition, function is even. If we replace x by minus x and the symbol of complete function changes, symbol of function changes, then it is our odd function. A function having some change, no change, it is neither even nor odd. How to hunt them, we are coming on that. Let me start from this one. As I have dearth of space, f of x is equal to x cube minus x over all x square plus 1. In order to check whether the given function is even or odd, just replace x by minus x, replace x by minus x, replace x by minus x in that fashion. F of minus x, we have minus x cube minus x over all minus x whole square plus 1. Look at this. Minus x raised cube, power is odd, minus remains, power is overall 1, minus remains, it will become minus plus, it will become minus, and this minus will become neutral, even owing to the power of square, owing to the power of square, owing to the power of square. Let me see whether I am in frame or not. I am at very low space. I am writing, we have done this definition, odd, even. If x is replaced by minus x, no change. If f minus x gives us complete change in the symbol, it's odd. Then we have to check. I am checking this function again in a good fashion to give you good idea. Look at this. We want to check this is even or odd. Even or odd, replace x by minus x. Starting in reverse fashion, retrospective fashion. This one. Replace x by minus x. I have minus x cube minus x overall minus x square plus 1. Power is odd, minus remains, power is odd, minus remains. It will become minus x cube minus plus x. Here power is even, minus will be converted into positive automatically. Now look at this, how to decide. It's really very simple. If I take minus common from the numerator, I am in a position to tell what happened. Minus common, I have x cube minus x overall x square plus 1. Look at this here. Symbol is positive. Positive x cube minus x upon x square. This minus means f of minus x is equal to negative times the original function, negative times the original function. F of minus x minus, we have taken common from the numerator, x cube minus x over x square plus 1. Now if I replace this quantity, it is value of f of x. Its value of f of x. Its value of f of x. I have replaced this minus f of x. Look at this. It is definition of odd function. It is definition of odd function. So this is our odd function. This is our odd function. I have just done nothing except replace x by minus x. Then check the power. Power is even, minus will become neutral, power is odd, minus intact. There is minus intact, minus minus plus. Then I have taken very delicate step, minus common from the numerator, x cube minus x over x square plus. Look at this. It is the complete function. Complete function we have as it is. Just accept this symbol. I have written this symbol. Instead of this, I have replaced by f of x, and it is the definition of odd function. If x is replaced by minus x, then the whole symbol of whole function changes. Symbol of whole function changes. It is odd. It is odd. So this function is odd. This function is odd. Okay, let me erase this. Generate a space and going upwards. The sky is the limit. Let's see and find out. We have done with this. Another good question, cumbersome, a teaser for students, a teaser for a student. Why it is a teaser? F of x, x raised to over 3 plus 6. Owing to the power of the fraction, owing to the power of fraction, x raised to over 3 plus 6, owing to the power of fraction, it is hard to decide whether it is even or odd, or how to handle it is even or odd. Let's see and find out. Just replace x by minus x. X by minus x, there is 2 or 3 plus 6. Now the game starts. Now the game starts. Where to go? Where to go? It's really very easy. It's really very easy. Let me write this thing as minus x raised to 1 over 3 overall square plus 6. Look, this power is even. This power is even. If negative sign is intact, owing to this even power, it will become positive. It will become positive. It will become positive owing to this even power. Whatever the result of this one, if it is negative, owing to the virtue of square, it will become positive. So I have x raised 1 over 3 over 2 plus 6, or one can write x 2 over 3 plus 6. We have replaced x by minus x, and the function remains same. So this is the definition of even function. Or let me tell you simple flat rule. This is the decisive factor. If it is numerator is even, this fraction works as even. If if numerator is odd, then this fraction works as odd. In that case, the numerator part of the fraction is even. Numerator part of the fraction is even. It works as even. That is the ample proof that I have done. I have split 2 over 3, yes, 1 over 3 times 2. Whatever the result is, if minus intact, it is even. So it all depends upon the numerator's part of fraction. If it is even, this fraction works like even. If it is even, this fraction works like even. If it is odd, this fraction works like odd. In that case, it is even. I have turned negative into positive, so it is our even function. We have replaced x by minus x. And there is no change. It is our even function. Making another step by raising this and going towards question number 4. Mostly the students ignore whatever is mentioned here. It is known as mathematically restriction constant. It means that x is equal to minus 1 has been excluded from the domain. If we put x is equal to minus 1 here, then the function is undefined. That is the value or logic of this restriction. You must read this as well. If we put x is equal to minus 1 here, the function will become undefined. So we are forbidden in that case, in that function, you can put whatever you want except x is equal to minus 1. Because at x is equal to minus 1, it is undefined. It is indeterminate form. Let us focus, check it's even or odd. Replace x by minus x. Here, minus x minus 1, minus x plus 1. Okay, cool. Taking minus common from numerator, I have x plus 1, and from this minus common, it will become x minus 1. Minus minus cancelled out. What I have? It is x plus 1 over x minus 1. Look at this. The function is not same. The function is not same. The function is not same. Neither the function remains same, neither the function remains same, nor the symbol of complete function changes. Nor the symbol of complete function changes in that case. Changes in that case. There was x minus 1, now it is x plus 1. There is x plus 1, now it is x minus 1. So it is neither even nor odd. Neither even nor odd. If each and everything remains same, would have remained same, then we say that it is even. If overall symbol changes, if that is the case, minus x minus 1 over x plus 1, then we can say that it is odd, but neither is the case. Neither is the case. That is something after replacing x by minus x. It is neither same nor x has been replaced by minus x. No symbol change completely. It is some sort of mix. Neither even nor odd. Neither even nor odd. So it is our neither even nor odd function. Moving towards question number 3. Making the space, generating the space. As we move along, we have let me erase this as well. What about this? It seems to me what? Let's see and check. Replace x by minus x minus x square plus 5. We have to change, replace x by minus x throughout without any exception. We have to replace x by minus x in order to check whether it is even or not. X I have replaced by minus x, owing to the power of even, it will become positive, minus will become neutral, minus x, it's overall x square plus 5. Look at this. This complete function remains same. If I introduce x instead of x times x square plus 5 root, I can write f of x. So it is minus f of x, minus f of x. So when we have replaced x by minus x, it is equal to negative f of x, and that is the definition of odd function. That is the definition of odd function. Here it is overall positive, in that case it is overall negative. So function is odd. Function is odd. In that case, function is odd. Okay, cool. Moving toward another question. What about this? Just replace x by minus x. Okay, minus x plus 2 whole square. What we can do? You can open whatever. Even if I take minus common inside, it will become x minus 2 whole square. Owing to the power of even, minus will become positive. It is equal to x minus 2 whole square. Look at this. It neither remains same nor the symbol of complete function changes. Half symbol has been changed, half remains same. Half has been changed, half remains same. It is neither even nor odd. It is neither even nor odd. Look at this. We have x plus 2 minus x plus 2, half change, half not. If we have taken even minus common, then x will become positive, y is negative. Owing to the virtue of this power even, minus will be converted into positive. I haven't written. So this is also some change. Neither remains same nor symbol completely changes. It is somewhere between. Symbol of x has been changed. If we have taken minus common, symbol of 2 has been taken. It is somewhere some mixture of neither even nor odd. Neither it remains same nor the symbol of complete function changes. Here there are two terms. Symbol of one term changes, one remains same. Symbol of one term changes, symbol of one term remains same. So it is neither even nor odd. Let me conclude this once for all, then we can erase this. Question number 9. Even or odd, replace x by minus x. I have minus x cube plus minus x. Moving to the power of odd, minus remains, minus plus minus. Taking minus common, as usual, x cube plus x. It is overall function. Again, instead of this, I can replace x minus f of x. Means f of minus x is equal to negative f of x. F of negative, when we replace x by minus x, the symbol of complete function changes. Symbol of complete function changes. It's neither even, let me write, neither even nor odd, and it is complete symbol change. It is our odd function. It is our odd function. It is our odd function. We have done with question number 9. We are done with question number 9. Let me erase this completely, and we are going to have a good space now. Here, you will learn all these things in your analytic geometry phase. This is the equation of parabola. Mention it is ellipse, it's hyperbola, circle. By the way, it is missing. I will write circle for you. X is equal to r cos theta. In your book, it hasn't been written. R cos theta and y is equal to r sin theta. These are the polar coordinates, are parametric equations of circle. Parametric equations of circle. Parametric equation of circle. Look at this. If in case of sine and cos, these letters are changed, these letters are different, they are not equal, then it's equation of ellipse. Equation of ellipse. If they are identical, if a and b are equal, then it is, these are the parametric equations of ellipse. Sorry, ellipse, circle. If they are same, they are parametric equations of circle. If they are different, in case of sine and cos only, then it is ellipse. If different, ellipse. If same, circle. Let's see and verify. Parametric equations. These are the parametric equations of hyperbola. Just replace x by a sec theta, y by b tan theta in that case. Let's prove. X means a sec theta whole square over a square minus b tan theta whole square over b square is equal to 1. There is no plus minus symbol. I can distribute the power throughout. It is a square sec square theta over a square cancelled out. Here b square theta tan square theta over b square cancelled out. It's equal to 1. So I have sec square theta minus tan square theta is equal to 1. These are identities. R1 can write sec square is equal, instead of sec square, one can write 1 plus tan square theta. This is the value of sec square minus tan square theta. Cancelled out. So 1 is equal to 1. 1 is equal to 1. So we have proved x is equal to a sec theta and y is equal to b tan theta. These are the parametric equations of hyperbola. In that case, transverse axis along x-axis and conjugate axis along y-axis. If transverse axis along y-axis, then our equation would have been changed as well. Okay. Let's prove the equation of parametric equation of ellipse. X is equal to a sin theta, y is equal to b sin theta. In that case, major axis along x-axis and minor axis along y-axis. Let's just replace x and y here. X means a cos theta whole square over a square. What about this? B sin theta whole square over b square. There is no middle symbol. I can distribute square. A square cos square over a square cancelled out, plus b square sin square theta over b square cancelled 1. I have cos square theta plus sin square theta. Everybody is familiar? Or you can replace value of cos square, it is equal to 1 minus sin square. They are cancelled out, or it is itself identity of sin square plus cos square. So x is equal to a cos theta, b is equal to sin theta, represents parametric equation for ellipse. Moving on a step further, we have parametric equation of parabola. Here it is y square is equal to 4a x. What is y? Y is 2. 2at whole square. 4a times x is 80 square. The square of 2 is 4a square t square. 4 times a, it will become 4a square t square. Both sides are equal. Yes, it is parametric equation of parabola. It's parametric equation of parabola. Let me solve. Let me verify parametric equation of circle for you as well. X square plus y square is equal to r square. Replace x by r cos theta whole square, y by r sin theta whole square is equal to r square. Distribute power throughout, r square cos square plus r square sin square is equal to r square. Taking r square common, I have cos square theta plus sin square theta is equal to r square. We are familiar, it is called unity. R square times 1 is equal to r square. R square is equal to I square. Yes, these are the parametric equations of circle having center at origin and radius equal to O. Radius equal to O. Okay, cool. Moving towards question number 6. As we have garnered much space now, it's a good question. A stone falls from a height of 60 meter on the ground. The height h after x seconds is approximately given by h of x is equal to h of x is equal to 40 minus 10x square. A stone falls from height initially it is given to us 60 meters. 60 meters. From at a height of 60 meters, a stone has been dropped. A rock has been dropped. Okay. What is the height of the stone after x is equal to 1, after 1 second, after 1.5 second, after 1.7 second? Just simply put the values here. After 1 second, what is the position of the rock or stone after 1 second? Put here h of 1 40 times 10 minus 1 square. 40 minus 10. 1 square means 1. 40 minus 10, 30 meter. After 1 second, it is at the half height. 30 meters. So overall 60. It is at 30 meters after 1 second. Similarly, one can put 1.5 and 1.7 to find these values B and C. Question number 2, part number 2 is a good one, having some depth. When does the stone strike the ground? When does stone strike the ground? Can anybody guess? Yes, we can guess. When a stone hits the ground, obviously, when this rock hits the ground, this stone hits the ground, then height must be 0. When height is 0, then it has smashed with ground. Means when height is 0, the stone touches the ground. This is the equation. H of x 10x minus 40x square. When it touches the ground, our height is 0. Then solve for time. 10 minus 40x square is equal to 0, or 10 is equal to 40x square. Dividing by 40 in order to find what is time, by the way, here? I think the time is 40 minus 10 square. Sorry, it is 40 minus 10 square. 40 minus 10 square. Shift 10 here. Equation was 40 minus 10 square. 40 minus 10x square. 40 minus 10x square. When it hits the ground, obviously when height is 0, then the stone hits the ground. Solve for x. Shift 10 here. 40 over 10 is equal to x square. X square is equal to 4. So x is plus minus 2. We take only positive 2. After 2 seconds, the stone hits the ground. One can verify from this. After 1 second, the stone has traveled half mark, exactly half mark. After 1 second, The stone has traveled half mark, half mark. After another 1 second, 30 meter for first second, 30 meter for another. In 2 seconds, definitely this stone is striking the ground. This stone is striking the ground within 2 minutes. Within 2 minutes. Okay, cool. That's something concept in physics. When does the stone hits the ground? When does? Means when height is zero. When height is zero. Okay, cool. Moving towards question number 5 now. 5. Let me don't. Function is given to us. F of x is equal to some cube sort of function. X cube minus x square plus bx plus 1. F of 2 is given to us minus 3 and f of minus 1 is equal to 0. Then we are asked to determine the values of a and b. Simple one it is. 5. F of x is equal to x cube minus x square plus bx plus 1. Let me check the data once again. X cube minus x square plus bx plus 1. Yes, and furthermore, we are given two conditions. F of 2 is equal to minus 3. Function value at x is equal to 2 is minus 3. And function value at minus 1, it is equal to 0. It is equal to 0. Okay, utilize both of these conditions. F of 2. Replace 2 instead of x. 2 cube minus a2 square plus b times 2 plus 1. F of 2, it is given to us. F of 2 is equal to minus 3. Minus 3, 2 cube 8 minus 4a plus 2b plus 1. 2 cube 4a plus 2, good. 8 1 9, shift 3 here. So we have minus 4a plus 2b, 8 and 1 9 plus 3 will become positive. 9 plus 3 it will become 12. 8 1 9, shift minus 3 here, it will become plus 3, 9 plus 3 12. Applying table of 2 throughout in order to lighten the burden of calculation. 2a plus b plus 6 is equal to 0. That's our equation number 1. Let me get another equation from the given condition. F of minus 1 is equal to 0. Replace x by minus 1. F of minus 1 here minus 1 cube minus a minus 1 whole square b times minus 1 plus 1. F of minus 1, it is given to us, it's 0. Minus 1 cube means minus 1, it will become minus a, negative b plus 1. It is cancelled out. It is cancelled out. Okay, bingo. We have minus a minus b is equal to 0. Minus a minus b is equal to, this is our equation number 2. Solve both equations. Equation 1 is solve 1 and 2. Solve 1 and 2. We have minus 2a plus b plus 6 is equal to 0. And second one is minus a minus b is equal to 0. Just add them up. Cancelled out. We have minus 2a minus a minus 3a, that is plus 6 is equal to 0. 6 is there. bb cancel, minus 2a minus a plus 6 is equal to 0, or minus 3a is equal to minus 6. So a is equal to, a is equal to 2. Value of a is 2. Value of a is 2. Put in any equation. May I do it again? Yes. There is a little space. I cross the frame. I am solving this again. There here we have solve 1 and 2, that is minus 2a plus b plus 6 is equal to 0, and minus a minus b is equal to 0. Add up. Minus 3a plus 6 is equal to 0. 6 is here. Minus 3a is equal to minus 6. A is equal to positive 2. Put in any equation. Let me put in tiny one. Minus a minus b is equal to 0. A is minus 2. Minus b is equal to 0, or minus b is equal to 2. So value of b is minus 2. So value of a is 2 and value of b is minus 2. Value of a is 2 and value of b is minus 2 in that case. One can verify by putting values here whether we are giving or not. Let me verify one thing for you. So we have now f of x, x cube minus 2x square minus 2x minus 1. 2x minus 1. A is 2, b is minus 2. I am verifying the first condition or second. Okay, I am putting 2. F of 2. It will become 2 cube minus 2, 2 square, 2 times 2 minus 1. Here is minus 1 or plus 1? There is plus 1. Let me write plus 1 here. It will become 8. It will also become 8. Minus 4 plus 1. So minus 4 plus 1, it is equal to minus 3. It is equal to minus 3 as the given condition. As the given condition. One can also prove 0. One can also prove 0 by putting x is equal to minus 1. Minus 1. Minus 1 cube. Minus 1 square. Minus 2 times minus 1 plus 1. It will become minus 1. Minus 2 minus minus. Plus 2 plus 1. Look at this. This cancel. This is also cancel. And f of minus 1 is all 0. Bingo. We are 100% correct. Okay. Moving towards further how to find domain and range. Then some hyperbolic identities. And we are going to work wonders in that case. Here. Good one. Gx. X square plus 3x plus 2 overall x plus 1. Here x does not equal to 1. I have already told you if we put x is equal to minus 1 here, so it is our exception. We cannot. For domain and range, for domain we have done 3 things. I have already explained in any video. Let me again. For domain, denominator doesn't vanish. Denominator doesn't vanish. Does not vanish. Vanish means does not become 0. Denominator does not become 0. Second, no negative result occur in square root. It is not allowed. Third, for log ax, a must be greater than 1. A must be greater than 1. These 3 things we have to respect for domain. For domain, look at this. We are asked to find its domain. It's really cool. It is a rational function but can be simplified. Middle breakup. X square, it will become, first let me take denominator, x plus 1 is equal to 0, so x does not equal to minus 1, so its domain is going to be all real numbers excluding minus 1, excluding minus 1, excluding minus 1, excluding minus 1, the rest is the domain of this function, the rest is domain for this function. What about range? Factors are possible and this is a common factor. This is a jump or hole. This is a jump. This is a jump. Factorize this, x plus 1 automatically cancelled out. Then we are in a position to manage some value at x is equal to minus 1. How? Let's see. G of x. It is x square. Middle breakup 2x plus 1x plus 2 overall x plus 1. Taking x common. X plus 2 plus 1 common. X plus 2 overall x plus 1. Here. X plus 1 other bracket is x plus 2 overall x plus 1. Look at it, it's a jump. We have x plus 2. We have x plus 2. Even without putting x is equal to minus 1, even without putting x is equal to minus 1, we can find the value of this one. But it is known as limit value. Limit value. Put x is equal to minus 1. That we are forbidden. Put x is equal to minus 1. It will become minus 1 plus 2. Minus 1 plus 2. It is 1. So from domain, we have to delete minus 1. From domain, we have to delete minus 1. From range, we have to delete this limit value. That's limit value that we have utilized using limit. So our range is complete real number excluding this one. From the domain, we have deleted minus 1 because it gives us undefined situation, indeterminate situation. Utilizing the concept of limit, we have factorized and this is a jump. We can jump through it. We have find the value. That is 1. But it is limit value. At the graph, when x is minus 1, and this one is 1, we have to show here a jump, a hole. Means minus 1 is not in our domain, and the corresponding value 1 is not in our range. So its domain is all real numbers excluding minus 1. The range of this function is all real numbers excluding 1. Why? Because corresponding minus 1, the limit value is 1. limit value is 1. It is not function value. It is limit value at x is equal to minus 1. It is limit value at x is equal to minus 1. Minus 1 has been excluded from domain and 1 from the range. Okay, we will moving towards next question. It is also, it's simple one. It is very traditional question. It is also a jump at x is equal to 4. Let's see and find out how. Our function is f of x is equal to x square minus 16 overall x minus 4. Look at this, itself is given to us, x is equal to, means for domain how we can add, we take the denominator, x minus 4 is equal to 0. So x is equal to 4. So domain is are all real numbers. Domain is all real numbers except 4. Domain is all real numbers excluding 4, because at 4 this is undefined, this is undefined. Here even without solving it is mentioned to us. But what is the corresponding limit value at x is equal to 4 to be deleted from the range? To be deleted from the range, let's see and find out. Find its limit value at x is equal to 4. Limit x tends to 4. Solve this function x minus 16 over x minus 4. Middle term, sorry, difference of 2 square. Limit x tends to 4. It will become x square minus 4 square overall x minus 4. Limit x tends to 4. We have x minus 4, x plus 4 overall x minus 4 cancelled out. Put limit 4 plus 4 is equal to 8. 4 plus 4 is equal to 8. So our range going to be all real numbers. Our range is going to be all real numbers excluding 8. 4 is not included in the domain and the corresponding limit value at x is equal to 4, which is 8, is not included in the range as well. This is the exception at x is equal to 4. In the same token, we have to hunt what is the exception is going to be in the range. We have evaluated using limit at limit x tends to 4. The result is 8. Result is 8. X is equal to 4 has been excluded from the domain. So the limit value corresponding to x is equal to 4 has been also excluded from the range. Okay, cool. Moving towards some piece functions. Now they are cool, simpler, not typical, easy to explain, easy to understand, easy to comprehend. Let's see and find out what I have now. Here, 6 g of x. These are known as piece functions. X minus 1 when x is less than 3. Okay, cool. 2x plus 1 when 3 is less than or equal to 3 is less than or equal to x. Look, there is no concept of denominator. It is continuous everywhere. There is no square root, there is no log, just simply calculate. In that case, we are forbidden x. We cannot take x is equal to 3 for this. Less than 3, less than 3, less than 3, less than 3. If I utilize x is equal to 3 for this, g of x at x is equal to less than 3 means 2.999. Let me write 2.9999999 minus 1. It is going to be 1.99999. Almost it is equal to 2. Almost it is equal to 2. So the domain of this one is completely familiar. Domain is all real numbers, all real numbers, all real numbers. First exception is minus infinity to 3, and second one is 3 to positive infinity. 3 to positive. That is our domain. That is our domain. And what about if I put 3 here? Then it will be g of 3. Exactly x is equal to 3. That's the interval to be taken. 2 times 3 plus 1. It will become 7. It will become 7. So the range is going to be minus infinity to discard this 2. 2 is not included. 2. 1.99, but 2 is not excluded. Let me write in that fashion. Open interval. Open interval means 2 has been excluded. 2 has been excluded from the range. Union, then for this interval, minimum value is 3. Minimum value is 3. The range starts from 7 to positive infinity. 7 to positive infinity. Here, we are not in a position to take 3. I have taken 2.99999. 2.99 gives me 1.999. In order to give you clarity, I have written open interval. Open interval means 2 has been excluded. 2 has been excluded. Open interval. 2 has been excluded. 2 has been excluded. Mean I can take all the values 1.999999, not exactly x is equal to. Not exactly x is equal to. That's why I have written 2 is open. 2 is open. From the side of 2 it is open. 2 is not included. 2 is not included. However, 7 I have included because 3 is less than or equal to 3 is less than 3 can be fitted here. I have fit 3. It will give me 2 times 3, 2 times 3, 2 times 3, 6, 6 plus 1, 7. I have written 7, 7 to infinity. So that is the range in that case. That is the range in that case. Similarly, one can take all the values from this one, x2 to this one, this. That will give you a good idea about modulus, square root, and so on. Here I have g of x. G of x is going to be mod x minus 3. For absolute value, everybody is familiar. Whatever the result is, whatever we put instead of x, it is going to be something positive, something positive. At least value of x, if I put x is equal to 0, then it starts from 3. 1, 2, 3. The V shapes is formed from here. X is equal to 1, 2, 3. X is equal to 0, it starts from 3, 3. Whether you put negative values or positive value, it will result in positive values owing to the definition of modulus function. And we are familiar what is the graph of modulus function. We are familiar. So domain in that case is going to be all real numbers, or you can write minus infinity to positive infinity, open interval, and range starts from, I think if I put this, if I put 3 minus 3 is 0, it is going to be from 0 here. Range is going to be from 0 to positive infinity, 0 to positive infinity, 0 to positive infinity. Range starts from here. The range starts from here. If I put 0, it will give me minus 3. But whenever I put 3 minus 3 is 0, it starts from here. It starts from here. It starts from here. That's why I have made some correction into that. So our range in domain in case of modulus function always positive. You can put positive or negative, but its graph has been erected towards positive y-axis. Either you put positive or negative values, it results in positive. If you put positive values, absolute value will also always give you a positive quantity. Absolute value function will always give you a positive quantity. Okay, cool. What is this? G of x is equal to root x plus 1. It's really simple one. Now there is no denominator, but there is square root. There is square root. Good one to be handled, x plus 1. What we cannot afford, negative values in the square root. Negative values in the square root. Negative values in the square root cannot be afforded. Negative values in the square root. Overall negative result cannot be afforded in square root. So how to deal this one? X plus 1 is greater than or equal to 0. It must be positive or 0. Or x is greater than or equal to minus 1. X is greater than or equal to minus 1. So our domain is going to be in that case, minus 1 is exclusive. From minus 1 to positive infinity. From minus 1 to positive infinity. It is inclusive. Negative 1 is inclusive. Negative 1 is inclusive. Range is always what sign here? Positive. Range is always positive. Positive means 0 to infinity. 0 to infinity. If I put x is equal to minus 1 here, minus 1 plus 1, the minimum value of the range is starting from 0, 0 to infinity, 0 to infinity, 0 to infinity. However, let me share with you an interesting idea. If the function has a slight change like this, g of x is 1 over x plus 1, 1 over x plus 1, then what is the change in that domain of this function? What is the change of what is the change in the domain of this function? It's really classical. I have written x plus 1 greater than or equal to 0. 0 in the numerator is affordable, it is 0. We cannot afford 0 in the denominator. We cannot afford 0 in the denominator. So here explicitly I have to write x plus 1 is greater than or equal to 0. So x is greater than minus 1. So from the range, from the domain, I have to exclude minus 1. From domain, I have to exclude minus 1. I write in that fashion, minus 1 to positive infinity, minus 1 to positive 1. Look at this. Minus 1 have been discarded. Minus 1 have been discarded. If I put minus 1 here, minus 1 plus 1 in denominator, it give me 0. That's the violation of the definition of domain. Slide change. Slide. Look at this. Root x plus 1 in numerator. I have taken x plus 1 is greater than or equal to 0. If I put x is equal to minus 1 plus 1, 0. 0 is affordable in numerator. If same function lies in the denominator purely, then I have drop this equal sign, x plus 1 is greater than 0, x is greater than minus 1. So that is going to be our domain, minus 1 to infinity. Minus 1 has been excluded, look at this, minus 1 has been excluded for this, for this 0, minus 1 has been included, look at this, I have shed it. For this it is valid, for this it is not valid, it is not valid. Or what about the graph of this one? To guess its graph, it's really very easy. But after doing some algebra, geometry, then you are in a position to do good guess about this. Look at this, g of x is equal to root x plus y. We are familiar, g of x means y is equal to x plus 1 root. Squaring both sides, I have y square is equal to x plus 1. So either square in x or in y. It represents a parabola. That is covering both portions of positive and negative, and x is minus 1 from here. That is the graph of this parabola. This is the parabola. Squaring both sides, g of x means y square is equal to x plus 1 whole square. Either x is square or y. It is the equation of parabola. It's equation of parabola I have mentioned. This is your straight line. Nothing to worry about that. All real numbers, domain, all real numbers, range, all real numbers. What about this? It's good nut to crack as well. G of x is equal to x square minus 4. How to find its domain? Really very interesting. G of x is equal to root x square minus 4. In square root, we need positive values. X square minus 4 greater than or equal to 0. Why greater than or equal to 0? My function is in the numerator only. In denominator, there is only one. That's why it's safe to put x is equal to here. Square of 2, 4 minus 4, 0. 0 is affordable in the denominator. 0 is affordable in the square root. If square root is in numerator, that is the case here. So x square is equal to 4. Or mod x is here, one cannot solve. What about this? That is equal. Mod x is greater than or equal to 2. One cannot write this one in open interval. It means there is, if that is the case, mod x is less than or equal to 2, then everybody is familiar, from minus 2 to 2, that's our interval. If that is the case, then opposite is the situation. It means that we have to exclude minus 2, minus 1, 0, 1, 2. Here that's 2. Here that's 2. Means we cannot, it means we have to discard the middle portion. There is a reason behind this. Why? Put x is equal to 0 here. 0 square minus 4 results in negative. It is imaginary value. What about minus 1? 1 minus 4, it is also minus 3. If I put 1 here, 1 minus 4, 3. If you are going to put all values between minus 2 to 2, means between minus 1.99999 to 1.99999, you are going to get something imaginary, in that case. So how we write the domain of this one? Really very interesting to note that. If that is the situation, greater than or equal to Means we have to discard this interval. We have to discard this interval. Read that. Read the outer limits. That's minus 2. That's 2. It depends upon the situation. Our function is in numerator. Square root is in numerator. Minus 2 works. 4 minus 4 0. This 2 also works. 4 minus 4 0. 0 works in numerator. 0 works in numerator. It's good. The bit value between values from minus 2 to 2, open interval from minus 2 to 2, open interval from minus 2 to 2 has been discarded, deleted from the domain. From the domain. How we can write domain in that case? Domain is going to be negative infinity and minus 2, union from 2 to positive infinity. Positive infinity means all portions up to this deleted, as well as the portion from it is included. This portion has been excluded. Minus infinity to nearest minus 2. From this to this complete portion has been excluded. Look at this. Minus 2 to 2. This portion we have deleted. All real numbers from negative to positive. All real numbers from negative to positive. But excluding this portion. Excluding this portion. Minus infinity to minus 2. Minus infinity to minus 2. Included. From minus 2 to positive 2. Excluded. This portion is excluded. Then from 2 to positive infinity included. Included. And all range of a square root function is always positive. Range of this one is from 0 to positive infinity. From 0 to positive infinity. Range of this one is positive. It depends upon and the outer symbol. That is, by the way, positive. That's why positive real portion is the range in that case. It is range. It is range. Okay, cool. Moving towards the final questions. The good one, the simple one. Now I am going to take not much time. Not much time. Why not? Why not? I am sipping some water. Okay, cool. Okay. Express the following. Express the following. Number 1. The perimeter of a square as a function of its area. Perimeter of a square. Perimeter of a square as a function of its area. Perimeter of a square as a area as a function of its area. What is perimeter? Let me draw a square. Square means all dimensions equal. X, 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 x. So obviously perimeter is 4 times x. What about area? Area is x times length times x. X times x means x square. X square. Now we have to express perimeter as function of its area. Perimeter as function of its area. Find x from here. X, taking the square root both sides. I have x is equal to root a. X is equal to root a. So replace this x here. So perimeter is going to be 4 times x, or perimeter is 4 times root a. 4 times root a. It is read as we have expressed perimeter as a function of its area. 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 Perimeter as function of area. Perimeter as function of area. However, it is not mentioned. I can express area as a function of perimeter. 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 Here a is equal to 4x. Sorry, a is equal to x square, and perimeter is 4 times x. 4 times x. Find value of x from here. It will become p over 4. P over 4 replace here. A is equal to p over 4 whole square. So area is going to be P square over 16. P square over 16 means we have expressed area in terms of perimeter. Area in terms of perimeter. Area in terms of perimeter. While here perimeter in terms of area. Perimeter in terms of area. It's simple one. Perimeter 4x. Area x square. Common tip is x. Utilize x. Find value of x from here. Put in perimeter. It is perimeter expressed as area. From perimeter find x, put in area, it is area expressed as perimeter in that case. Really very cool concept. Number 2, the area of a circle as a function of its circumference. Area we are familiar, pi r square, circumference 2 pi r. R is the common link, connecting link. Find value of r from one, put another, it's going to get through. Area of circle, it is r pi r square. Circumference 2 pi r. 2 pi r. The area of a circle as a function of its circumference. Function of its circumference. Manage r from here. C over 2 pi. That's value of r. Put here. Area in terms of circumference. Area in terms of circumference. Area in terms of circumference. From circumference, find the value of r. Put here. A is equal to pi times r means C over 2 pi whole square. Simplify. Pi times c square over 4 pi square. Cancelled out, pi remains. I have c square over 4 pi. C square over 4 pi means we have expressed area of circle in terms of circumference. Area of circle in terms of circumference. Area of circle in terms of circumference. While circumference can also be expressed in terms of area of a circle. Like this, c is equal to 2 pi r. Find value of r from here. How we can find value of r from area of circle, that is pi r square, or a over pi is equal to r square. Taking square root, we have a over pi is equal to r. Put here c is equal to 2 times pi. R means root a over pi. If we manage to cancel this out, under root comes on pi. It will become c is equal to 2 times root pi. Circumference in terms of area. And while it is area in terms of circumference. Final question. The volume of V of a cube as a function of its base area. It's also cool. Volume of cube we are familiar. Volume of cube means x times x means x cube. While area of the base is a square. Base x it is our x square. Now volume is going to be x cube. Base area is going to be x square. What we are asked? Volume as its base area. Base area. Find value of x. X is going to be root of base area. Shift, put here. V is going to be root base area or area of square base area overall cube. One can write V is equal to base area 3 over 2. Means we have expressed volume of a cube as a function of its base area. Volume of a cube as function of its base area. I am really got tired. Moving towards final. Identities of hyperbolic. Very tiny to prove. Let me get through this as well. Prove the trigonometric identities. Number 1. Sine hyperbolic 2x. Sine hyperbolic 2x is equal to 2 times sine hyperbolic x cos hyperbolic x. It is the identity that is also present in trigonometric function, and that is parallel. Sine 2x is equal to sine x cos x. So there is no difference. Knowing the fact that 2 sine hyperbolic x is equal to e raised x minus e power minus x over 2. That's value of sine. What about cos? E raised to x plus e power minus x over r2. Quite amazing. 2 cancelled out. If I can, here a minus b, a plus b, difference of two situation, difference of two square situation, difference of two square situation. It is going to be e x whole square minus e minus x whole square. Power having another power, multiply the powers, it will become 2x, it will become e power minus 2x over 2. Look at this, look at this. It is tantamount to what? This is 2x, this is our angle. So it is equal to sine hyperbolic 2x. How sine hyperbolic 2x? We have proved. Twice sine hyperbolic is given by e raised x minus e raised minus x over 2. Cos hyperbolic, the only positive sign is there, e power x plus e power minus x. 2 cancelled out, a minus b, a plus b situation, difference of 2 square, a minus b, a plus b, it is equal to a square minus b square, e x square, e minus x square, power having another power, multiply the powers, and this is the identity of sine hyperbolic 2x. So number 1 proved. What about number 2nd and 3rd? Let me prove one for you at least. Cosec hyperbolic x, cosec CSC, cosec hyperbolic square x minus 1 is equal to cot hyperbolic square x minus 1. Okay, cool. There is only cosec hyperbolic. Cot is equal to cos over sine. Cot is equal to cos over sine. Means e power x minus plus e power minus x over whole square. That's minus 1. Cot hyperbolic square. Cot means cos hyperbolic over sine hyperbolic. Cos hyperbolic means e power x plus e power minus x over 2. Sine hyperbolic e power x minus e power minus x over 2. 2 to cancel, that is the situation. Now how to open whole square? Let's see and find out. A square, it will become e power 2x plus twice e power x times e power minus x plus e power minus 2x divided by, what about this? E power 2x twice first and second e power x times e power minus x plus e power minus 2x minus 1. Taking LCM, look at this, they are cancelled out because base is same, add the powers x minus x, e raised to 0, e raised to 0 is equal to 1. Any non-zero quantity is having 0 power is equal to 1. Similarly this one as well. What we have, what remains? Let me write e power 2x plus 2 plus e power minus 2x overall e power 2x minus e power 2x minus 2 plus e power 2x. Taking LCM, it will become e power 2x minus 2 plus e power 2x. Multiply minus throughout. What remains? Let's see and find out. E power 2x plus 2 e power minus 2x minus e power 2x minus minus plus 2 minus e power minus 2x it is. Here it is. Here also e power minus 2x. Bingo. I am right now. E power minus 2x. Something cancelled out. It's negative. Positive, it's negative. What about this? This is positive, this is negative, cancelled out. What remains here? E power 2x minus 2 plus e power minus 2x. Let me manage the show in the upper portion. Let me write this. 2 plus 2, 4 over e power 2x minus 2 plus e power minus 2x. That is going to be cosec. I can write this one 2 over e power x minus e power minus x whole square. This 4 can be written as 2 square. This is the complete formula of e raised x minus e raised minus x. It is the reciprocal of sine. It is the reciprocal of sine. It is the reciprocal of sine. Means it is cosec hyperbolic x. Cosec hyperbolic x. Cosec hyperbolic x. It's my one I have left for you as exercise work. Please think about it and attempt in the same fashion. I got that tired. It's my time here for you guys to teach you inter mathematics. I have more to come. Let's see and find out what will happen next. Let's solve by itself. Next.